All right.
Good evening, everyone. We are starting the today's session, which is to introduce you to the Spark machine learning library, which some of them you need to use for assignment number 2. So the agenda today, next slide, Yelena. We are going to talk how we are evolving in the course of big data and what are the new skills. Actually, this is very interesting topic, which I'm just going to start it, and would be great until the end of the course you somehow find a place in the classroom in the discussion forum to discuss about this, because this is very important. This is part to discuss not only the topic we are studying, but also the skill which are needed for the data scientist. And then some key reminder for assignment number 2 to keep very important stuff in mind regarding the Jupyter notebook, the markdown, parsing function. Let's put it this way. This is one of the key things in assignment number 2, where if you are able to create your parsing function, this is almost, let's say, big chunk of your assignment. And this is a key. Without this, you cannot succeed in this assignment. So that pay attention what Elena is the hint she is going to give you about the parsing session, how to use the pipeline, and then some tip regarding part 2 of the assignment, and of course, example, as always. You will get an example on logistic regression model with different data, the data you are going to work in your assignment. And then we are going to put you to some bonuses you can get in the assignment when you do certain stuff. And of course, the most important payoff is you stay here in this valuable time of the evening. You can ask your question immediately. Next slide. So I just wanted to point out here how our course of big data analytics evolved, and that I want to point your awareness about this comes with new skills. And you can feel it because this class is quite different than the other classes. It's not like 630 and 640, focusing mostly on machine learning to solve different type of problem through different approaches to create the model. Here we are getting to the next phase, which is how to do analytic on big data, which include not only the data, but include, we talked this from the beginning of the class, is the technology to deal with this data is the key. We are going to use the same machine learning algorithm you have worked with in 630 and 640. Here we are going to use them with different technology. You are going to work in the cloud. So this is just the paradigm shift, how technology works in order to deal with big data, which are textual data, images, big size of data, variety of data, complexity of data, understanding of natural language understanding. So all these imply new approaches to use the same algorithm, new approaches with new technology. And the new skills you are learning already in very intense fashion. And we as your instructor are aware of this, and everything is going good so far. We are very happy the way you are learning all these difficult and many new stuff related with technology in order to apply them to complete your assignment. So mostly here in big data, we are talking about additional skill, not just building model. We are talking about data engineering skill. You have to deal with how data can be stored and accessed when we talk about big data. We talk about Hadoop distributed file system, which is one of the way to store and access this way the data. we talk about HBase, which is columnar database, and we discuss briefly some of the new SQL databases and data lakes, which are important in that direction. So one part is how to store data, then how to access this data. All this is more data engineering and data management skills than in addition to building model. So this is very important, and we'll be happy to hear in the discussion forum discussing more about these new skills, any data scientists, and how much of them you must have. Let's put it this way, because there is no straight line division what is data scientist and what is data engineer, because each of them must have a little bit from the other skill. So that is what we are talking about. Data scientists with a little bit of data engineering skills in this class, a little bit, because for much you learn, actually, this is just the beginning of the data engineering skill. And it comes with using the cloud. You understand this, that the big difference of what you have been doing is that you are doing the stuff now in the cloud for several reasons, because big data cannot be accessed in other fashion. You cannot work with them in your personal computer. And the software to process this data, like engine mechanism, like MapReduce or a Spark, are not going to perform in a single computer. They need a cluster computing in order to perform. So there is no choice. Whatever job you are going to evolve in your career, there is no choice. At some moment, your employer will ask you to work in the cloud. And very convenient, we already have talked about this, that is less expensive. The company doesn't have to do any management, in very convenient to outsource the information technology to some cloud provider. And you then, as a data scientist, data analyst, you have to perform your work in the cloud. Very important is the things you are learning during these 5 weeks. You have learned a lot of this, is how to use services in the cloud, how to manage them, how to manage the resources, and you learn very important thing, which is the difference, how you use the resources in your personal computer, which are there and they are there at your hand, and how to use the shared resources in the cloud, which are shared by multiple users, and that's why they are less expensive, but are more powerful. Cluster computing in the cloud. So as such, you are learning how to manage these resources. You are learning that if you are not using the resources, you have to stop the service. And this is one of the key things. The same thing you do with the water and the electricity in your home. If you're not using the water, you close the pipe. If you are not using air conditioning, you don't open the door and the window in order to freshen the air outside of your home, right? So it's exactly the same thing. And I see very good advancement in this direction, and we are going to learn much more about the technology for big data in this class over the following weeks. So I want to give the presentation to Elena, which is going to proceed with the help session about the service, the library, Spark machine learning library you will need to use for this specific assignment. So the technology you will be using for assignment number 2, Elena.
Yes, and there is a little bit, I might sound like a broken record because it has been said, and I have to repeat this. Do not enter the credit card number. Please, 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 please. You're not gonna get more resources, and please, because once you do that, that's it. Your account is not gonna be academic account anymore, and then we have no clue how to help because we don't have a non-academic account, okay? So please, please, please do not do that, okay? Please do not do that. We had people who do that and then they're in trouble. There are additional reminders, so please do not upgrade your account. You have to remember that you need to stop the runtime environment before you exit to avoid consuming all your hours, right? So when you close the browser tab, are you stopping the environment? No, right? So if you accidentally close the browser tab, you want to log back in and stop the environment as you should, right? You want to stop the kernel, and then you want to make sure that nothing is running, right? And remember the videos that you watched for the Spark tutorial, right? Sometimes you may need to watch it again just to remind yourself what you need to do when you exit, okay? Now, please do not open any IBM tickets. They're not gonna do your homework. They don't know what you need to do, right? Instead, you're gonna submit what? The Salesforce ticket, for instance. You're not gonna call the service desk, right? When you submit the ticket, you want to select the correct type. Otherwise, I'm not gonna get it. It's going, I don't know where, okay? Now, you have to upload the data to the project before you add the notebook. Do not delete the object storage. Remember, object storage is a location where the data actually gets saved. For each project, a bucket is allocated, right? So that's what it is. Do not delete the object storage. There could be problems. Do not open two notebooks in the edit mode at the same time. Remember, in the video, I showed you that the notebook can be opened in the view mode or in the edit mode, because when you open it in the edit mode, you're gonna just you're gonna start the environment, right? Now here, this is important. When you run your notebook, you cannot skip any cells. Otherwise, you're gonna get error, right? You must run the notebook starting from the top all the way down, right? Just please remember this, please, please. Now, you have to make sure that you select correct runtime environment. At the moment, it's still Spark 3.2, Python 3.9. Warning, if some of you end up submitting the assignment late, there is a high chance that the environment gets either updated to a new one, something like that. So, because we use the same environment in the summer, and just before the Spark, before the Spark tutorial assignment was released, this version was the latest one at that moment. But you never know, and if you are submitting it late, or if you're getting an I for the course to complete the assignment, beware that this could change. Okay, just beware of that. Okay, well, this is a little bit about the syntax, and I have an example for you, but in the example, I use different notebook, not the notebook that you use for the assignment, but here I just broke down. When you double click on a cell, right, markdown cell, you see the notebook title. Jesus predicts survival for Titanic passengers. If you see one hash mark, then this is a title, right? Notebook heading. Then you're gonna see the double hash mark. It's a level 2 heading, right? So, oh, okay. Well, for this assignment, oh, excellent. You can create a new project, or you can reuse the existing project. Do what works for you. Do not do what works against you, okay? Well, do what works for you. You can create a new project. Absolutely. In theory, yes, it's a good idea to create a new project for each assignment. Excellent question. Yeah, I would say yes. Okay, now, this is just text, right? Well, what's going on in here? You have a heading, level 2 heading called table of contents, right? And then what those are, you have the menu, so hyphen, right? So that indicates the bullet point type. Then it's a link, and that's an anchor where it's going to in a notebook. So let's go and actually look at the notebook. So here, this is one of the projects that I did for you, and here is the notebook. What I'll do is I'm gonna open a notebook in a view mode. Well, I can't open it in the view mode. Do you know why? Because I won't be able to show you the markdown. I have to open it in the edit mode, unfortunately. So I'm opening in the edit mode, and as soon as I do that, what happens when I do that? My runtime environment is starting. So now I have to be careful, okay? But I have to do it because I need to show you the markdown here, okay? And you're gonna get this example. So basically, this data is to predict the risk of the heart attack. So it's loading. See that the environment is starting, and see, so now it's gonna start consuming the hours, but I have enough hours, so no worries. Okay, well, do you see this when you put double click here? It's gonna show you the markdown. See, this is the main heading. And then over here, this is a table of contents. What is this? This is a location. This is the position of in the document. Right? See this ID, foreign data. So see that this is the anchor here, right? And in here again, double heading. What is this? This is a link. This is an external link to the dataset source, right? So here you have it. What is displayed and where it's going, right? So if I was going to return it back to Markdown or run it, right? I need to run this, and it's gonna be displayed again. Well, so you see that? That's what it is. This is the link. This is how you do it. It's an external link, okay? Oh, my voice comes in and out. Okay, I'm gonna try. Do you guys hear me? Can you hear me?
Yes, we do.
Okay, I'm gonna try to sit a little bit closer to PC. Okay, now. Well, what's going on here is I went over this, right? And hyphen, this is it tells the bullet type to use. That's table of contents. Next thing, well, what is this? This is a table, right? And the table has how many columns? 1, 2, 3, 4 columns, right? So remember that if you used HTML before, there is an HTML syntax for the table. Well, you have the table opening tag, you have the table closing tag. You have a table row, right? Table row is a row. Then you have a table data, it's a cell inside the, it's a cell inside the table row, right? But what's done here is, this is one image, right? To make it look nice, you have to make it a row span. So the cell in the first row, here in this row, it spans across multiple rows. So how is that done? So if I double click here, well, see this? I've got the table tag and the closing table tag. Well, this is the first table row, right? Now here I have this, the first cell, right? It just nothing, it's just blank. Next one, it's a heading that says variable. The next one, the heading says description, right? So this one, it's an image. This is the external link to an image. This is IMG tag, right? And then SRC specifies the URL, and the image must end with JPG or PNG, whatever image you are adding, right? So this is a closing tag. This spans across 17 rows. So next 16 rows are gonna have one cell less, right? Because this cell, it spans across 17 rows, right? So here is just listing all of these columns and descriptions. So I'm just gonna run this. And when you run it, it just shows how it looks like, right? So this is the picture on the web. And here is the descriptions of my columns, all right? So you want to predict a 10-year risk of coronary heart disease, and this column is binary. 1 means at risk and 0 means no. And you're using information such as gender, using age, education, and then some of this, if the person is a smoker, number of cigarettes per day, if the person is taking blood pressure medicine, and etc. Okay, and you are using this data to predict if the person is at risk. Well, here it's more columns than what you have seen, right, in your homework example. Okay, so well, now we're gonna get to parsing data, but what's happening actually? Well, let's look at what's happening. You have the data set, right? The data is where you're reading the data from the CSV file, right? What is a CSV? Each row is a comma delimited list, right? In order for this to work, you have to write a function that converts the file to the set of labeled documents, right? Well, so in here, this is what I recommend you do. First of all, you want to list the columns. The way it's done in the Titanic notebook, I'm doing the same thing in here. I'm gonna list the position number and a column name. Why? Well, it's gonna help me later when I actually work on writing the code. But please take your time doing it here. Remember that in Python, the first element is labeled as 0. Starts from 0. So you have a comma delimited each row is a comma delimited list of value, and the first value in that list is at position 0. It's patient ID, then it goes male, age, education, and etc. Right? So here it is. Now, what you need to note in here, patient ID is at position what? 0. This one is it that I want to predict is at position what? 16. Okay. Now you have to write a function that returns. This is a data type label document. Label document consists of what? See this three part. First part is the column that I'm gonna do. This is a patient ID, right? So this is a unique identifier. Person info is gonna be the concatenation of the columns that I want to use to predict this label, right? And what is label? In my case, label is going to be this column, right? It's going to be this column because this is what I'm trying to predict, but do not change this word label. It has to be like this. This one is person ID, person info, right? And then you got label cannot be changed, the word label. Well, what I'm doing here, I tried multiple combinations of predictors, but, well, first of all, I'm reading, right? This function takes one line and it's trying to split the values. The values are comma delimited, right? The value at position 16, this is my, what, independent? No, this is what I'm trying to predict, right? So what I'm doing in here is this. First of all, the label value of a label has to be either 1.0 or 0.0, right? So it's 1.0 when the value that's being read is greater than 0, right? When it's a 1, it's a 1. Well, otherwise, it's 0. This is a concatenation of the predictors. What columns am I using here to predict by risk, right? Here, right, what is this? This is a position. Values of 1. This is the first value is at position 0. What is coming at position number 1? If it's a male or female, right? Male. Then comes age, then comes education, and etc. This is what I'm doing here. I'm just what I'm doing there. It's nothing but just the delimited list. I'm just preparing this part. In here, well, this one, right? I tried different combinations. I'll tell you why. And what does it has to return? The function returns labeled document. What is this? Remember, labeled documents, you need to pass the unique identifier, right? This is the concatenation of the predictors, and this is what you're predicting. That's it, right? That is it. But I'll tell you, most of the time, when the students are not getting the results they need, their error is here. Because what they do is they take the parsing function from the Titanic data and then don't change it. They overlooking these things here, the positions. And very often the students predict if a mother is a smoker for the low birth weight instead of correct column, right? Because you have to pay attention in which position. You need to know what are you predicting, what are your predictors, and in which position in a line as they're located. Because see, you're reading what? A row at a time. You're parsing one row at a time. See, it's taking one line from your document, right? And what else is going on? Where are we calling it? So, well, first of all, see this? This is where you read the data. So how many times credential block appears? Once, right? You read the data once, then here it's gonna be 2. You need to change to 1 because that's where you use. That's the names that you use going forward, right? This is important. You want to add this in for schema equals is true. Otherwise, when you do analysis on columns such as age, you're not going to be looking at the age itself. You will end up analyzing the ASCII value of age. Also, this piece is very important. Don't forget this, right? In for schema, true. Now, in here, what this is doing, I'm going to scroll. Oops. Okay, so this is just reading data. This is data explorations. I'm gonna skip a little bit to that section where, oops. Okay, well, in this case, what I'm trying to predict is in position number 16. Okay, well, I'm not gonna tell you where it is in the low birth weight data, but in this example, it's in position number 16 because what I did was I saved myself a lot of time just by listing the columns in here. Well, this will save you a lot of time. See this? I took that list over there. If you look at this, I took that list and I relabeled it. Well, actually, this exactly like here, right? And I just put it here just to make sure it's next to my code. Okay. Well, if you do this, it's gonna save you a lot of time. Trust me. Now I'm gonna skip a little bit the exploration because I want to get to the place, and I'm gonna talk about that too. Well, okay, so this is what's going on in here. You're gonna be calling, right, that function. Okay, but here, wait, this is still you're looking at you're still reading the data frame in here, right? So here nothing happens. It just showing you how many rows are in data sets that were read. This is what you're reading. This is a line in a file. See this? Those are just the first 5 lines in the file. The first line contains column names, and the next lines contains a limited list of values, right? This is just nothing but shows the rows, and you're previewing the first 5 rows here. Now, I'm going to scroll back. Okay, what is this doing? Well, take a look at this. The first row is column heading, right? In this case, you have to remove the column heading row. You want to keep just the value in this specific case. You want to remove the column heading. How do you know which column heading? It is a column heading if the row contains patient ID. See, if the row contains this text patient ID, then this is column heading. And you want to remove. This is, remember in Python lambda function, right? So what you're doing is patient ID, not in S. So S is a line that you're reading from the file, right? And you want to take the line if it does not contain the word patient ID. And you call in that parser function. See this map? What it does? It's calling the parse document functions that we looked at a minute ago. And then it's creating the data frame. Here I'm printing the number of records, and I want to output 5 records. Attention here. If you see the column names here, right, in the first row, if you see the column names, it means that you did not remove the column names from data, right? If you see the column names here in the first row, it means that you did not remove the column names, and your output is going to be wrong. You need to go back to the drawing board. You need to fix the code, okay? Well, then what you do is, as always, we're gonna split the data into a test set and a training set, and I'm using 70% and 30% in this case. Here's just the output, right? Here I'm running my logistic regression model, and I'm using the tokenizer function, right? And what I did was I just spelled out for you. Well, you define the label, right? In your example, it was 1.0 if survived, 0.0 if died, right? Then you defining the custom function as we just did, right? And then just calling the function. Well, here I just did more explanation for you. What is this in your homework assignment, right? How things go. Okay. Now you're using the pipeline. Pipeline consists of what? 3 stages: tokenizer, caching, and the method calls. So basically, here is what is doing the logic here, right? So the pipeline is going to call logistic regression feed method, and it's going to produce the model. Okay. So I'm looking over here. Well, this is where it's doing, but I already ran, and I'm going to give you with output to save you a little bit of time. Okay. Well, then what you need to do is you run it for the training data to build the model. Then you're going to evaluate the model performance on the test data, right? You do the prediction for the test data. So here, this is just the tabulation of the outcome, right? You are looking at how many, you're looking at the predicted outcome and the actual outcome, right? You want to compare with that. So how many actually are at risk and how many are not at risk versus how many predicted at risk all right. So this is one way just to show the summary, the actual label versus the predicted label. This is not confusion matrix like you used to seeing it, but it just well, it just telling you that the column is the actual label and the row is the prediction, and it just showing you some data, right? But here you need more, right? What do you need? You're not just looking at the how many are correct, right? You're not just looking at the accuracy. There is more than you need to look at. Let's take a look at this. What you're doing in here? Well, you need to look at the accuracy of a model. Here we're looking at the training set, right? So if you look at accuracy is 95%, which is too much promising. Error, right? Precision, recall, you have to look at this. You have to look at F measure also, right? Then you're evaluating the method on a test set. You have to compare if the difference between the accuracy is too big, what's going to happen? You are overfitting the model, right? Well, okay. Basically, what's happening in here is a training. You have a training data, right? It's a data in a training set. And you're trying to actually build the model that's gonna predict. You use the trained data to build the model here, in this case, to predict if the person has the risk of the heart attack in 10 years, right? So you have the actual value and you have the predicted value, right? So the actual value is the value that's in the data versus the value that is predicted. You have to compare predicted with the actual, because if you were doing this, remember in data 630, at least I remember that you used R and then you build the model, right? You had the training data where you build the model. Then you had the test data where you removed the label. Then you applied the model to the, you ran the model on the test data, right? Which generates which predicts, right? Makes a prediction, and then you do comparison with the actual value and see how accurate the prediction was. I mean, I hope I explained the question. Predicted value is what the model predicts. Like for example, you have the patient information, right? And based on that, what does the model predict if the person is at risk or not? And then we know we have the actual values and we need to compare, right? If at risk, right? If the model predicts that you're at risk, are you actually at risk? So how many rows do we have where the person who was predicted at risk is actually at risk? You know what I'm saying? Or sometimes if I'm predicting that the person is at risk, but the person is not, right? So you have to look at that. And you've got these measures that you need to see, right? So this is a little bit of your homework. You need to understand why we're looking at F measure. Okay? Okay, good. You have to look, you need to understand why we're looking at the F measure, and also you're looking at the area under the rock curve. Well, another thing to point out, the area under the rock curve always between 0.5 and 1. If you receive the area under the rock curve under 0.5, go back to the drawing board. Something is wrong in your code, okay? You need to go back and fix it, okay? So you're looking at the false positive rate versus the true positive rate, right? So like false positive, for example, I predicted that the person is at risk, but actually the person is not, right? And true positive, I predicted that you're at risk and you're at risk. So you have to look at this area here. All right. So you need to pay attention to that, right? You want to look at the values. Okay, now let me take a look. I talked about the pipeline. Well, okay, this is remember this line? Well, because when people forget to add this line, when they read data, the data types are read incorrectly and the analysis are going to be wrong. And I'm going to show you about the analysis. Oh, this is just about the data that I'm using, for example, right now. Well, I did a little bit of bonus for you. Okay, you need to do the histogram, for example, to look at the age distribution, right? In this specific case, I have a lot of columns and a lot of columns are numeric. I could go ahead and draw the histogram one column at a time, but maybe I got a little bit lazy and I want to do it all of them, right? I want to have a nice figure where I do all of them. So I pass the data frame and then I pass the vector of column names. I specify number of rows and number of columns that I want to see in the output. And I'm gonna do, see this, I'm looping here through all of these columns and I'm visualizing all of them. Yes, I'm visualizing all columns in here basically. And let's go back to this code. You're gonna have a copy. You're gonna have this notebook, okay? Oh, it's in here. Well, see this? Instead of doing this, see this? I'm doing a histogram for one at a time. I want to do that, where I'm gonna loop through my columns, and I'm gonna do this. See this? I specified the number of columns and I specified the number of rows. So this is a function definition and it's calling it here. It is taking pandas data frame as an input, right? Then here, well, this is just, it returns the columns. This is pandas data frame dot columns, returns the columns. Then you've got the number of rows and number of columns. And what it's doing, it will just plot each, the distribution for each column. Okay, well, that's what it does. Another thing that there are no mission values in this case, but this is how you would check if there are any. Is null, okay? Well, here, this will return how many values are missing in a column. This you have to convert this to pandas data frame, and you're gonna check if it's null and then do the sum. See, this is what you do. And this is just how to see the data frame, the information like column data types, etc. Right? In this case, I read it correctly. See, if the age is character, then you need to go back and see if you are if you edit the line to enforce schema equals true, right? So that's a good check here. Right, so what you do, you have a regular data frame, right? And you have the RDD to run the method, but the data frame is just for the analysis. So you want to look at you want to do the describe. In describe is going to give you the count, which is the number of rows. It's going to give you the mean value, standard deviation, minimum, right? And the maximum 25% all, 50 and 75% all. So this is what it's going to give you, right? This is similar to summary comment in R, except the summary comment in R does not give you the standard deviation. All remember? Okay. Now, here, this is a histogram code. You're going to have this. What else I did here? You can do the pairwise plot, and you need to use the Seaborn package here. This is a package that you use to produce this, but it took a little bit to run. This is a correlation plot. In here, there's a correlation heat map, and you have some of the options that you can choose. Okay, not just figure size, and you choose the colors. Well, I didn't choose the colors here, but I just did this line width. I changed the line width. Okay. Well, in here, the color code indicates the correlation between two columns. But what you can see right away is that you have a column that tracks if the person is a smoker. And then you have another column that tracks the number of cigarettes, right? The person smoked. But take a look, if you smoke at least one per day, then you are a smoker, right? So for your analysis, you want to keep probably just one of those. And if you find that column, you're gonna see the correlation, right? You're gonna see that. So basically you want to look at if your predictors are independent, right? So here, this is the darker the color code, right? Oh, this is negative, remember? It goes between -1 to 1, right? So you look at the color code and like for example, see this 0.78, this is a diastolic and systolic blood pressure. Well, of course, usually if your upper reading blood pressure is high, usually the lower reading is also going to be high, right? So you see that, right? Well, there are a lot of decisions for you to make. In this case, you have a lot of columns. You want to look at the correlations, and you want to make sure that the predictors I use are independent. Oh, here it is. See this? If the person is a smoker and the number of cigarettes per day, here you want to make some decisions. You want to use ones, but not both. You want to use one, but you don't want to use both, right? And etc. So, well, this is back to the parsing data and all of that. So while I've been talking to you about this, what's happened? What's happened to my hours? Up, up, up. They're going up, right? If I want to, and I have to, I'm going to stop the kernel. I'm going to shut down if I'm done working, right? I'm not going to leave it running tonight. Why? Because I will run out of hours. I won't have any hours to help you or to test the next assignment, right? Okay, so I'm going to stop this. Oh, you want to go over regression model results? Okay, we will. But I'm going to go to the view mode. Well, let's do this. Well, okay, I'm going to do, first of all, before I do anything, I have to make sure that I stopped. I go to administration, and I'm going to go to the environmental runtime, and I want to make sure, thank goodness, nothing is running. But you see this? Last time I used 0.3, I guess. Sometimes it takes a little bit of time to refresh. Oh, here we go. Well, this is what I've used, right? And I have been working for how long now? I've been talking for half an hour. So this is what I've used, right, so far. Oh, I want to give you another hint here. For your Titanic notebook, all you have to do is the credentials block and the bucket name. So if you're doing it right, you should not be using more than 0.2 for your part one of the, or part one of your assignment 2, first part, it's given to you. All you have to do is do the credentials part, right? Credentials block. And then in another cell, you have to change the bucket name. That's it. Well, that's it. So there is no coding. Unlike in the Spark tutorial, you had some coding to do. There is no coding. So you're gonna be, yeah. Okay, now let's go back here. Well, results basically the accuracy of the model, right? So I need to go back. How do I go back? I have to go back to here, projects, and I can do view all projects, and I was in a Spark demo project. Okay. Well, now I want to look at the results, but I don't want to look at the, I want to look at the results, but I don't want to edit anything. I want to save my hours. I'm gonna go to view in here. Well, okay, so now, what do I see this? Well, it's in the view mode. Nothing is running, right? I ran this for you, and here is the model. Then, well, I'm not printing the actual model. What I'm doing is just running it on the training data to see what the accuracy is. And I'm also doing this on the test data to see how accurate, to see the, how accurate, right? You want to compare if the accuracy on the training data is way higher than the accuracy on the test data, then it's what called? Overfitting, right? So now I'll go down. Oh, here it is. I'm parsing the data. Here I'm splitting the data into training and test, right? Okay. You're starting. Well, yes. Oh, yeah. Okay. Thank you very much for bringing it up. Yes, everybody is starting with less than 10 hours. Please ignore that line. Everybody is starting with less than 10 hours. Please ignore that line. I thought it was deleted. Everybody is starting with less than 10 hours. Absolutely. Because you only got 10, okay? You only got 10. It should say if you're starting with less than 8 hours. Okay, it should say if you're starting with less than 8, then I need to be aware. All right, but 8 still should be enough to do the assignment, because maybe it takes like half an hour for the first part. Everything else, save it for the second part. And some of you, I heard that in earlier coursework you used an application to for editing notebooks, right? You can do that if you want, to create your notebook and then upload to here to run. You can do that too, right? You create a notebook somewhere else and then upload to run, right? Okay, so here data is split into the training and test, and I'm calling this thing to predict the model sees pipeline fit. Here is just doing this. It's returning the person ID, all those information that we use to predict. Here is a predicted value, and how it determined is this. It's looking at the it's looking at the probability of a 0 and the probability of a 1, right? So well, here prediction is 0 because the prediction sees it for 0, the probability is higher, right? It looks at all of this. I'll see here, this one prediction is 1 because the first number shows the probability that it's 0. The second number shows the probability that it's a 1. And this number is higher, then the predicted value in here is a 1, okay? That's what it's doing in here. Prediction is a 1. And here you just basically, okay, so it just taken this none with the highest probability. See this? Here the highest probability is that it's a 0, and the prediction is 0. It's looking at that, then it's tabulating it, right? You have to somehow determine how accurate your prediction is. And it's accurate when the actual value matches the predicted value, right? So you're gonna see, okay, you have 0.0 value, right? You want to look at, you tabulated the predicted outcome, then you look at the actual. Then you want to look at each row. You want to look at how many rows you have where the prediction is 1, predicted is 1, and actual is 1, right? Predicted 0 and actual is 0. So you want to look at that, right? Then you just evaluating the model, right? You're evaluating the model on a training data. Then you have to apply the model to the test data. See here are the results on the test data. Well, of course, the accuracy, it should be lower. If the accuracy, well, if you have for the training data, if your accuracy is 90%, and here, if the accuracy is 40%, then you have a problem, right? You're overfitting the model. Remember in data 630, well, I'm not sure if you discussed it in 640, but in 630, we talked about overfitting the model, right? Overfitting and underfitting, remember that. Well, then also, if you're doing the analysis, right? If you look at the column counts, right? This is the columns that you're predicting. If you look at the column, you can see the imbalance in the data because you have way more rows with 0, right, than with a 1. See that? So your homework assignment is to look at the readings and see how you would want to handle this, right? Because in your part 2 data, right, you have an imbalance issue. Hint, hint, I never told you that, okay? So you want to do a little bit of reading on that. If you want to aim for higher grade, you want to do more on the analysis part, okay? So you want to do that, right? Just look at it. I'm just giving you some hints, okay? What you can do if the data is imbalanced, and most of it is a review. Then one of the questions in part 3 on overfitting, this is a review from your data 630. You talked about the overfitting and you talked about the approaches you can use to prevent overfitting, right? All right, and another thing I want to tell you is for part 3, please make sure that you answer questions in your own words. We do not answer a question as copy and paste text from the web. Well, we had a student in the past who did that, and the end result was not good. So please don't do that, okay? Well, I need to tell you that because it happened, okay? You do not answer questions as copy and paste text from the web. You want it to be your own words, right? So do some readings and do your own words, okay? Well, so you're gonna have this code, but let's see if I went over what I meant to, intended to went over, yes. Yep, and this is just showing, this is correlation heat map. Those are the packages that you need to use. Seaborn and then matplot library, right? And with this one, you need to be able to use the Panda data frame, right? So you have to import this Panda data frame if you have not already. And then annotation equals true. It means that I want to see the actual correlation values. I specify the lines widths, and I've got this nice map, okay? Correlation map with values. You don't have to do it, but I'm just giving you, I want you to walk away from this session with this example, okay? Then, very important, you have to save your notebook as HTML or PDF to turn in, okay? Okay? What do you mean result of regression model? Oh, wait. What do you mean result of regression model? Can you tell me that? We just looked at the result. What result are you looking for? This is a result here. This is a result. We are this, see, it's printing out every row in here. Well, oh, I see, you're talking about the coefficient. I did not print this out. I did not because it's stored as a key value pair. It's stored differently here. So I did not print this out, okay? So this I did not because it's stored as a key value pair. I did not want to confuse you here, okay? So that's why I did not, but this is the result. Actual value versus predicted value. Okay? Did I answer the question? Yes, okay, so here. So, well, you just mainly you want to compare, right? And then you want to evaluate on the test set and on training set. You want to look at the area under the RAC curve. And if the area under the RAC curve, if you get a number under 0.5, then you have to go back to the drawing board, okay? You have to save the notebook as an HTML. Remember from last assignment, you already did that, right? And how many files you'll be submitting? How many people cannot count until 3? 3 files. If you did not submit the output, if you did not submit the HTML or PDF file or the notebook, your work cannot be evaluated, okay? Just remember that. So before, when you upload stuff to assignment folder, before you click submit button, make sure that you uploaded 3 files as instructed, okay? Do not lose any points on this. And this is just another useful example where they're predicting if HVAC, the air conditioning system, is operational. So they're using the building logistic regression model to predict, okay? And they're looking at the actual temperature versus predicted in that example, okay? Okay, well, what do I mean overfitting? Okay, well, do you remember that you have the training data and you have a test data, right? What happens if my results for the training data are super, super good? The model is 99% of accuracy. And then I take the test data, I have a new patient, I have the new patient data, and the model is not performing really well on new patient. Only 40% of new patients are identified correctly. What's going on? Something is wrong, right? I'm overfitting. All right, I hope it makes sense. Because see this, when you went, it's just so accurate, super accurate on the training data. And then you have a new patient and you know the information, right? You know the patient information. And perhaps if I have 100 new patients and only 45 out of 100 got predicted correctly in the test data, oh, something wrong. What am I doing with my training data to train the model that it fits really well for that specific training data, but it does not work well when I have a new patient? So I hope it makes sense, right? So there is something that you need to do. And what can you do to prevent this? This is your homework assignment. Because if I answer it right now for you, then the instructor would have to submit the Salesforce ticket to add me to the gradebook. Because if I give you the answers, then who gets grades? Who gets graded? I do, right? So your homework is to review the overfitting from data 630 or data 640 if you used it there too. And you want to apply this to examples. Okay, no problem. I'm glad you got it. Yes. So no worries. That's why we have this session, so that you can ask those questions and then you're gonna get the recording, right? So I would like to hear more questions. We have a couple minutes at least. We have a few minutes for questions. Then I'll start asking questions. So hopefully nobody ran out of hours, right? If you're doing it right, 10 hours is enough. Then another thing is that don't wait until the next month, because next month you're gonna need hours for another assignment, for the next assignment, okay? Your hours will be reset to 10, but the problem is if you're not doing the work right now, you are wasting your September hours. If you're waiting until the last minute, if you're working on this assignment late, you're wasting your September hours, right? You're going to start using your October hours, but you need your October hours for the next assignment, right? So the next assignment, you're going to be using R. Well, it consumes a little bit less than Spark. Nevertheless, you need those hours. Be careful, okay? Please be careful. Please watch out what you do, all right? For this assignment, we have to do, yes, you have to do introduction. Okay, well, let me see. For this assignment, you have to do an introduction, yes, and conclusion. Well, you basically, yeah, you answer questions directly, actually. You have part 1, part 2, part 3, right? So part 1, what is the first question? I think it's asking you what data you're analyzing, right? Yes, in part 1, you look and it's asking that you answer it, because the way it's structured is that it's structured as introduction, then what you're doing for data visualization, right? And what are your method results, etc., right? Then there is analysis section. Which alternative methods could you consider, and you need to explain why, right? You're not gonna just say, hey, I want to consider decision tree, that's it. No, you need to explain why you think the decision tree might work for the data. Why is it gonna work better than like regression model, right? Remember, you have decision tree, you have naive Bayes, you have neural network, right? So but you need to consider, you need to explain why. So there's a little bit of homework here too, right? There is no right or wrong answer, but you have to show your analysis. You have to be able, no guarantee, but to aim for higher grade, your paper needs to have the results interpretation and analysis for part 1, and yes, then for part 2. But for part 2, you have to watch for that parser function, because if the parser function is wrong, you're gonna get wrong results, and you're not analyzing the correct results. See what I'm saying? So this is very serious mistake, because you're not gonna be looking at the correct results. Your analysis are gonna be incorrect, and etc. You know what I mean? So just watch out, okay? Well, yeah, in this case, it's more like answering directly, but you want to look at the rubric and you want to look at the actual questions. Make sure you don't miss any points. Well, actually, what you could do, or what do you mean you lost me? Look at the assignment. The assignment consists of 3 parts, right? Part 1 is Titanic data. Part 2 is another data. You have to write your notebook. You have to create the notebook. And then part 3, you have to answer the question. Part 3 is a theoretical, right? You have 3 parts. Part 1, Titanic. The code is given to you. You just have to run it and you have to discuss the output. Part 2 is a little bit, it has more weight, because you did not get the code. You need to write the code for part 2. Okay? You need to create your notebook. You can start from scratch, or you can use the Titanic notebook as a starter and edit. Okay, but for part 2, you're not given the notebook, you have to write it. And you have to do the analysis part. So go to the rubric, go to the detailed assignment description, and make sure that you answer every single bullet point in there, right? Some of it may require a little bit going in more depth for readings. No guarantee, but to get a better grade, there's a little bit, you need to go in more depth. You need to do a little bit beyond what I'm just talking about. You see what I'm saying? Because if I give you the answer right now, what's the purpose of the assignment, you see? I mean, does it make, I hope it makes more sense, yeah. But yes, you have to make sure. Like, see, you're gonna have data visualization, right? You're gonna have those plots. Take the output and explain what the plots show about the data, well, etc. Right? You can see like what's an age distribution. Okay. Is there any relationship between passenger age and if the passenger survived or died? Take a look at the passenger class, because if you look at if you watch Titanic movie ever, or if you read the book, you probably already know what I'm talking about, right? Who was put in the boats first, right? Who was saved from the ship first? Of course, people at the higher economic class, right? Remember, there were people in several economic classes, and how the boats were prioritized, right? But does the data show this actually? See, that's what you want to see, right? And I cannot give answers, because then I'm gonna get the grade, not you, right? You will get the grade, not me. I will get the grade, not you. but you're taking the class, so something is wrong, you know. I cannot give the answer, but I give you a lot of hints today. Okay? Does it make sense? I want to see more questions, but it's good. If you have questions, it means that you started working on assignment. So, oh, and another thing is that please do not post the graded code in the discussion. Do not do it, please, please. If you need help with the code, just submit the Salesforce, because well, something that fixes your error may not fix your classmate's error, right? And then you're being it's part of your grade, right? You need to be able to create that notebook for yourself and get help from me, okay? But you don't share your answer with your classmates. Please do not post the code in the classroom. And also I need to tell that some issues cannot be resolved in the classroom because I need to see your screen. Sometimes it involves script sharing, sometimes it's something specific that you're doing. So that's why you better submit the, in this case, you need to submit the Salesforce case, because that way, if we need a screen share or something like that, we can set up, right? So, I mean, don't wait until the last minute, because what's gonna happen if everybody asks for help in the last minute? You're gonna wait in line, okay? So don't wait and start working on this assignment. It's due next week. Yeah. So does it help? Anything else? I guess Professor Ozan, anything else you want to say? Or Professor Gorchova? Anything you want to add? Professor Ozan? No, you don't want to add anything? Okay, well, more questions? No? Because if there are no more questions, then we're gonna call it a night. But if there are questions, I'll answer. And you're gonna receive the slides. What else you going to receive? The copy of that notebook. Okay. So you're gonna receive the copy of that notebook and the slides. Okay, and the copy of the data and the recording. All right. So if there are no more questions, then I'm going to end the recording and end the session. And I wish you guys good luck with assignment 2. Oh, wait, we have a question. Did you use only regression model? Excellent. So you're required to write the code only for regression model, yes, but there is a theoretical part of the assignment where you discuss which models you would have used, right? You actually use just regression, but another part of the assignment asks if what you would have used and why do you think the proposed method would have worked better than regression. So see, so you want to look at which other models you would have used and why, right? Remember naive Bayes, remember the decision trees and the neural network, but you have to pick and you need to explain why. See, this is gonna be, that part is your homework, okay? And there's no right or wrong, but here you need to put your reasoning, okay? But you write the code just for the logistic regression. If you have time, if you have hours left, sure, go ahead and practice naive Bayes. You actually have an example to take away with you. In the classroom, there is an example. They might still be there on a naive Bayes for the Titanic. If you have hours left, why not? Go ahead and try it. Or you can, it's something for you to take away, with you. Okay? You can run naive Bayes in general, but here you ask to actually run logistic regression, but this is theoretical, which other models you could have used for this data? And do you think those models would have worked better than logistic regression model? So you need to kind of like, yeah, okay. Hopefully I answered the question. Anything else? No, those are excellent questions. I like it. No? Okay. Going once, going twice. All right. So we're gonna end this session. Stop the recording and end the session. And then thank you guys all for your time. So I'm gonna stop recording. Oh wait, I got another question. Oh, okay, no problem. Okay, end the session. Stop the recording.